Hey everybody, I just wanted to make a quick video talking through how to make the plots for the Crystal Violet lab. I think some of you are having trouble with that. And by the way, I do a similar thing in the lecture videos as well, so I would encourage you to make sure you're watching the videos for chapter 12 because I do go through and I do graphs for first and second order, and then also for the Arrhenius equation as well. So I'd encourage you to go and watch those, but I'm going to go ahead and talk through making the graphs for this. So what you're wanting to do here, and I've already put in my ID number, and it told me that I'm going to use data set 8, which I kind of doubt any of you are going to use, but maybe some of you will. What we're going to do is we're going to make 3 different plots for the first trial in an attempt to figure out if we have 0 first or second order kinetics, to determine what order our reaction is. And then once we know that, we only need to do 1 plot for the other 2. So for 0 order, let me just write these in first real quick. So we have 0 first and second. For 0 order, and actually I don't even think we need another plot for 0 order because it is just concentration versus time, and absorbance is proportional to concentration. So we actually don't even need to worry about converting to concentration. We can just use absorbance and it'll work just fine. So I actually don't need a separate column for 0 since I can just use this column. For first and second order, I do need to do some math, because if you remember the let me get my writing pad here. Didn't think to get that set up. Okay. The first order integrated rate law, it uses a plot of the natural log of the concentration versus time. So this is first order, and the second order uses 1 over the concentration versus time. And so we need to get data for the natural log of the concentration and for 1 over the concentration. And again, here we're substituting in the absorbance because it works fine to do that. And if you don't remember the integrated rate laws, I would encourage you to go back and watch those videos again. For now, just in an effort to keep this video fairly short, we're going to go ahead and make the data here. So we're going to click on the first column here of the first order data. We're going to do equals natural log, so ln, open parentheses, the data for trial 1, close parentheses, enter, and then I'm just going to double click to get it to fill in the rest for me. And then I'm going to do a similar thing here for the second order. So this is equal to 1 over that data. Double click and it'll fill it in. So then to make my 3 graphs, I'm going to do time versus absorbance 1. I wonder if it'll let me just select that whole column. Sometimes that works and sometimes it doesn't. Sometimes it gets confused. That might actually be correct. That might actually work. That would be pretty handy if I didn't have to click and drag. So let me try it with this. So here I'm going to click on this whole column and then hold down Control and then click the second column. Let's see if it'll work for this one as well. Oh, I think it is going to work. Good, good, good. Okay, so then time and second order data. And we'll make make a graph for that. All right. So, yeah, that second order data is definitely not correct. So if we look at these three sets of data here, we have the zero order, which is this one, first order, and second order. The correct order is the one that gives us a straight line. And so that is this one here. So I forget if you need to find the, I think you do need to find the rate constant for the different reactions here. Actually, yeah, I know you do, because you're going to use that for the Arrhenius equation. So the rate constant would just be the slope here, but positive. And so then for the other graphs, since we already know that our data is first order, what we're going to do is we are going to do the first for trial 2, and then the first order for trial 3. Again, we're only doing first order because we don't need to do the other ones. We've already determined that the reaction is first order. So we'll just do the same thing we did before, equals natural log, so that is the letter L and then the letter N, open parentheses, that data point, close parentheses, double click on the little square, and then just the exact same thing here, but with the third data set. And so if we do time versus trial 2, and we only need one time here because we're taking measurements at the same time for every trial, so we don't need a separate set of data for the time for each one. There's first order for trial 2, and then lastly here, first order for trial, trial 3. And so when you get the trend line for each of these, we will have three different slopes. Oops, that is not what I meant to do. I meant to make that 25, not 2. It's kind of hard to read size 2 font. So we have three different rate constants, and in the first tab there you'll have the three different temperatures. I believe those temperatures are also determined when you put in your ID number, and so when you're doing the Arrhenius equation you'll use these three rate constants and the three temperatures from that first tab. I'm not going to go through and make the Arrhenius plot here because in the videos, in the lecture videos, I do that in the videos there. I think it's maybe the third to last video, something like that. I make a plot with actually even more than just 3 data points. It had quite a few data points. So you can go and watch that on the YouTube channel to see how you put in the rate constants, take the natural logs of those, take the 1 over the temperature, plug those in, and then get the energy of activation and everything from that graph. So I think I'll leave it there for tonight. If you have any questions over this, feel free to email me. If not, good luck, and I'll see you next time.